Okay, so today's lesson is going to move on to the pH scale. So in a unit on acids and bases, we definitely need to know what the pH scale is and how it works. So you would have had a brief introduction to this in grade 10 science and basically just got acquainted with the fact that the pH scale is between 0 and 14. A neutral substance falls right in the middle at pH of 7. The lower pHs represent an acid and the higher pHs represent a base. We're going to go into a little more depth with it now that we're doing grade 12 chemistry. So let's take a look here. So the concentration of the hydroxide ion and the hydrogen ion in solutions is quite small. For example, stomach acid, which is concentrated hydrochloric acid, has a concentration of only 0.01 mole per liter. Okay, so that's actually, it's not a very concentrated solution of the acid, but that's just a kind of a representation of how many hydrogen ions would be dissolved in solution. So strong bases have H plus ion concentration around 1 times 10 to the negative 14 mole per liter, which is extremely low, right? Because if they're a strong base, they're mainly the hydroxide ion, not the hydrogen ion. The pH scale was devised by Sorensen in 1909, and it uses the numbers between 0 and 14 to express the hydrogen ion concentration in a solution. Okay, so we can say a strong base has an extremely low hydrogen ion concentration, whereas at the other end of the scale, we'd have a much higher, like a pH of say 1 would have a high hydrogen ion concentration in solution. So the pH scale is the negative logarithm of the hydrogen ion concentration. And in reality, because we've seen, we say hydrogen ion concentration, but it's actually this hydronium ion. So if you remember what happens when water dissociates is one of these hydrogens zips over and makes an H3O plus and leaves an OH minus. But we replace this H3O plus and we just call it the H plus ion for simplicity. Okay, so here's the calculation here. pH equals the negative log of the hydrogen ion concentration. So what is a log and what's a negative log and how do we calculate it? So suppose we have a number which we'll call A. Log A would be the number you would raise 10 to equal A. So for example, find log 10. Well, log 10 is what do we have to raise 10 to the power of to equal 10? Well, to solve this, we know that x would have to be 1. So log 10 is 1. Okay, so let's try another one just so you can kind of see the pattern here. Log 100 is 2, right? So if you look at it like this, 100 is equal to 10x. What does that x have to be equal to make these two sides equivalent? Well, 10 to the power of 2 equals 100. So x equals 2, so log 100 equals 2. Another one you could look at is log of 0.1 equals negative 1. So if you rewrite that out, 0.1 equals 10 to the power of x. Well, what does x have to be in order to equal 0.1? X has to be negative 1. So that's what a logarithm is. So on your calculator, what you're going to need to do is you're not always going to have just easy numbers to deal with, right? Where you can mentally figure out what the answer is. It's often numbers where you wouldn't know that off the top of your head. So you can use the log key on your calculator to simplify the calculations. So this is the sequence you would use of buttons that you would press. Your negative sign. There should be a button on your calculator that says log. The next thing you would punch in, obviously you don't have a key that looks like this. This would be a numerical value, whatever the concentration of the hydrogen ion is, and then equals. So let's try a few just to see how this works. So this says to find the pH for a solution where the hydrogen ion concentration is 0.005 moles per liter. So what we're going to do is pH, we know, is equal to the negative log of the hydrogen ion concentration, which in this case is 0.005 moles per liter. So in my calculator, and you should try this along with me just so that you can make sure you have it figured out, you would punch in negative, then log, and then you'd put in the concentration and press equals. And you should get the pH of 2.3. Okay, so a pH of 2.3, that's very low on the pH scale. Therefore, this would be an acid. Okay, let's try another one and see what happens. So find the pH for a solution where the hydrogen ion concentration is 3 times 10 to the negative 12. So significantly smaller or lower concentration here than compared to here. So you might anticipate if this concentration led to a quite a low pH of around 2, this concentration, that's a lot less hydrogen ions in solution, we should be getting a much higher pH. In fact, most likely basic solution, right? So let's just see. So the pH is equal to the negative log, and we'll plug in the hydrogen ion concentration. Okay, and that is equal to 11.52 for a pH. So definitely, this is an acid, this is a base, whoops. They're kind of at opposite ends of the pH scale. And if we look at our concentration of the hydrogen ion, that makes sense. There's a much higher concentration here and a much lower concentration here, which would lead us to the assumption that if we have a very low H plus concentration, we'd have a much higher OH negative concentration. And when we have that higher OH negative concentration, that's going to be a base. Find the pH for a neutral solution. Okay, so neutral means neither an acid or a base. So it should result in a pH of 7. So if this is the hydrogen ion concentration, and this makes sense, right? We know that this is in water. When we were doing our KW calculations, in water, the H plus and the OH minus concentrations are both equal to this, 1 times 10 to the negative 7, and that gives that KW value of 1 times 10 to the negative 14. Okay, so just to show that in the pH calculation, if you put in that value, you get a pH of exactly 7, or neutral. Okay, so let's kind of take a little further look here. So there's also this scenario where you can calculate you can kind of do this calculation backwards, right? So you can calculate the hydrogen ion concentration if you got the pH value. In this case, though, we have to do something called the anti-log of the pH. So you can either do inverse log, like your second function or your inverse key, or the 10 to the power of x key. So I would think this is the route that I'm going to show you, and you should all have on your scientific calculator, you should all have a button that looks like that, 10 to the power of x. So you would use this sequence, the 10 to the power of x, and then negative and whatever the pH value is. Now, what I noticed is some calculators, it depends, you may have to put in the negative pH value first and then press this button. So try it on your calculator and see which way it works for you. You might press it first and then put in your negative pH value, or you might have to do it these two steps followed by this one. So just test it out and see. It might work better if we actually do an example so you can see if you arrive at the correct answer. So what is the concentration of hydrogen ions in a solution with a pH of 8.5? Okay, so we're going to go, the H plus ion concentration is equal to antilog times, and now it's not, we don't use 8.5, we use negative 8.5. Okay, so what we're showing here is that it's like 10 to the power of negative 8.5. That's really what we're doing here. Okay, so if you do this sequence or maybe this followed by this, try both and see what works. You should get to 3.2 times 10 to the negative 9 moles per liter. Okay, so that's your concentration of hydrogen ions. So we'll compare this concentration. So we've got 8.5, so we're on the basic side of the pH scale, but just, a little bit above the neutral point. And we'll compare that to a solution with a pH of 2.7 and see how the hydrogen ion concentrations compare. Okay, so we're going to do H plus concentration. Now again, this is the same as, I'll just zip it over here, 10 to the power of negative 2.7. Okay, so what we would do is we write it like this, but we use this button here. Okay, negative 2.7. And what you should come up with is 2 times 10 to the negative 3 moles per liter. Okay, so this is an acidic solution, much higher concentration of H plus compared to this one that's slightly basic. It's a much lower concentration of H plus. So this would have a higher concentration of OH minus, and this one would have a lower concentration of OH negative. So the pH scale, you kind of know this already, but a pH of 7 is a neutral solution. Okay, so your hydrogen ion concentration is 1 times 10 to the negative 7 exactly. A pH of less than 7, so the lower numbers on the scale, means it's acidic. So your hydrogen ion concentration is greater than that neutral amount, 1 times 10 to the negative 7. And a pH greater than, there should be a 7 there, is a solution that is basic. Okay, so that means your hydrogen ion concentration is less than that amount. So this is something, you might have seen something similar to this in grade 10, and it just sort of gives some common, mostly household substances and where they fall on the pH scale. So you can see right at 7 at neutral, you've got distilled water. Okay, just meaning like it's been filtered and there's no minerals or anything in it. So the type of water that we use to prepare a solution or you do lab stuff with. If you go up, you'll notice that, so if you look at rain, is slightly acidic, rainwater. So it's got slightly lower pH, milk, pretty close to neutral. As you go up, so this would be the stomach acid, gastric fluid, the hydrochloric acid that's found in your stomach. Battery acid is a very low pH, lemon juice, vinegar, anything citric, like, or citrus, sorry, has an acidic pH. And then if you go on this side, the basic side, some things you'll be familiar with. You can see seawater. So distilled water is right at 7. Rainwater is acidic. Seawater is slightly basic. Baking soda is a common household base. So it's got a pH above 7. Lots of like cleaning substances or cleaning chemicals are basic. Milk of magnesia, that's something that you might, I don't know that anyone would have that in their house, but you may have like bleach, for instance. Doubtful if you have household lye, but usually like drain cleaner and stuff like that, those are all basic and have quite high pH values. Okay, so in addition to pH, there's also something called pOH. Okay, so if we know that pH is a measure of the hydrogen ion concentration, pOH is going to focus on the hydroxide ion concentration. So it's kind of the same calculation, but instead of using the hydrogen ion concentration, we use the hydroxide ion concentration. So pOH is the negative log of the hydroxide ion concentration. So another way to look at that is OH negative concentration is equal to 10 to the power of the negative pOH value. So let's calculate a few of these and see how it looks. So we're going to calculate the pOH of a solution that has a hydroxide ion concentration of 2.5 times 10 to the negative 3 moles per liter. Okay, so pOH equals negative log of 2.5 times 10 to the negative 3. And what that equals is 2.6. So now if you look at these two, so this has a much higher OH negative concentration than this one here, but we get a really low value. I'm just going to draw your attention to this. So a low pOH value is equivalent to a high pH value. pH plus pOH has to equal 14. So a pOH of 2.6 is in fact a pH of 14 minus 2.6. So what's that? 11.4. Is that right? So a low pOH is a basic solution. A higher pOH would be acidic. So let's just take a look. So calculate the pOH of a solution with a hydroxide ion concentration of 4.5 times 10 to the negative 10. So we'll take the negative log and we'll plug in 4.5 times 10 to the negative 10. And that equals 9.35. Okay, so again, if you want to see the equivalent pH, just subtract the pOH and see what you come up with. So 14 subtract 9.35 is equal to 4.65. So you can see a higher pOH leads to a lower pH. So this one would be acidic and this one is basic. So pH and pOH have to add together to equal 14. Okay, so for example, if the concentration of H plus ions in a solution is 6.4 times 10 to the negative 10, calculate the pOH of the solution. Okay, so first of all, what you have to realize here is we're given the H plus ion concentration, not the hydroxide ion concentration. So we will initially have to calculate the pH and from there, then figure out the pOH. So we're going to calculate pH first. So what we'll do is we'll take pH equals the negative log of the hydrogen ion concentration, 6.4 times 10 to the negative 10. Whoops. And that equals 9.19. Okay, so that's the pH. We want the pOH. So pOH is equal to 14 minus the pH. So 14 minus 9.19 is equal to 4.81. Okay, so as long as you can figure out one, you can always figure out the other just by subtracting it from 14. Okay, let's see what other types of problems you can come across. So a solution has a pH of 9.5. Calculate both the hydrogen ion concentration and the hydroxide ion concentration in the solution. Okay, so first of all, if we have pH, then we can definitely calculate this guy here. So let's do that first. So we're going to take H plus ion concentration, and that's where we do the anti-log. And we plug in not just the pH, the negative pH. So, right, remember, so this is kind of what we're dealing with here. 10 to the power of the negative pH. Okay, so this is what we do. So this is where we use that 10 to the power of x button on our calculator. And what we end up getting here is that the hydrogen ion concentration is 3.16 times 10 to the negative 10 moles per liter. Okay, so that's half of what we need to find out. We know the hydrogen ion concentration. We now need to know the hydroxide ion concentration. So if you remember back to our last lesson, we can use, if we know hydrogen ion, we can find hydroxide ion using Kw, right? Because Kw is H plus concentration times OH minus concentration. And we know that Kw value is always 1 times 10 to the negative 14, unless we're told otherwise. We kind of just assume we're at like roughly room temperature, which is around 25 degrees Celsius. So we'll set that equal to H plus, which is 3.16 times 10 to the negative 10 times our OH negative concentration. So I'm going to divide both sides by this 3.16. I'm kind of running out of room, so I'm just going to write my answer over here. Okay, so to get this answer, I have to divide by 3.16 times 10 to the negative 10 on both sides, and that will give me actually 3.16 times 10 to the negative 5, and that's moles per liter. Okay, so you can actually calculate, as long as you can get one, you can always get the other if you just use the Kw expression. Okay, next one. What is the pH of a solution if the hydroxide ion concentration is 4 times 10 to the negative 11 moles per liter? Okay, so this is just going to be, we're looking for pH, but we're given the hydroxide ion concentration. So we can only figure out pOH first, and then once you know pOH, you can figure out pH. So pOH is equal to the negative log of the hydroxide ion concentration. Okay, so when we calculate that, what we get is a pOH of 10.4. So if we know that, our pH is 14 minus the pOH. So 14 subtract 10.4, is equal to 3.6 for a pH. Okay, let's do one more. Okay, so this one says, what is the hydroxide ion concentration in a solution with a pH of 3.25? Okay, so I think the easiest way to tackle this one is if you know pH and you're looking for hydroxide, first find pOH, and then from there you can figure out the hydroxide ion concentration. Okay, so I'm gonna go 14.3, or sorry, minus 3.25, and that would equal 10.75. Okay, so if pOH is 10.75, okay, so I've just stopped trying to edit out interruptions from my kids, so hopefully you don't mind. So if we know the pOH value, we can then do this. The hydroxide ion concentration is equal to the anti-log, and you can then put in the pOH value, but it's the negative pOH value, right? So if you do that, right, because this is like saying this. Okay, so if you calculate that, and this would be that 10 to the power of x button, you get 1.8 times 10 to the negative 11 moles per liter. Okay, so that's probably your simplest approach to solving this problem. Okay, so we see that we need hydroxide. We're dealing with pH, which deals with hydrogen ions. So get ourselves over to pOH, and from there, then we can find the OH negative concentration. So there's a couple worksheets that go along with the pH stuff. I think it's worksheets 5 and 6. So you can try out some of these questions on your own and see how you do.